Welcome back. It's Kate as usual, and today we will be discussing forces. To start off, a force is an interaction of an object with its environment. Forces cause change in motion. To start moving, to stop moving, or to change direction. We measure forces in newtons. Now there are two types of forces we must remember. Contact forces, which contact between two objects, and field forces, which have no physical contact between two objects. An example of contact force would be catching a football. To show the forces acting on an object, we use a free body diagram. Since force is in vector, we use arrows to represent the force on the object. For example, as we see in this picture, tension is going up on the rope. This is because when a rope is pulling on an object, there is always tension. Next, we see gravity going down on an object. It always goes down from the center. These are the two forces acting on this object. Newton's first law says an object at rest stays at rest unless acted on by another unbalanced force. Inertia is the ability of an object to resist a change in motion. It does not accelerate. When it is like this following the law of inertia, all of the forces combined, which is the net external force, equals 0. The measurement of inertia would be mass. Note, this is not the same as weight. Mass equals kilograms. Weight is mass times gravity, so it can change on other planets. Through the first law of the forces, they must be balanced and at equilibrium, which means all forces can cancel out. An example of this is a 100-kilogram package is being pulled across the floor at a constant speed with a force of 500 newtons. Calculate the frictional force and the normal force. To start off, we always draw a free body diagram. Then we would write equations for the x and y direction. To start off, we'll do the x direction. We write down what makes up the external net force, which would be FA minus FF equals 0. Then we solve it, which means that the applied force equals the frictional force, which would mean that the frictional force is 500 newtons. Next, to move on to the y direction equation, we write down the elements, which is N normal force minus mg equals 0. To solve that equals N equals mg. Plug in the numbers 10 times 100, and that gives us the normal force of 1,000 newtons. That's how you calculate the frictional force and the normal force. Now, if the forces are unbalanced, the object will accelerate. Newton's second law states that acceleration of an object is directly proportional to the net force and inversely proportional to the mass. So we can use the formula F net equals ma. Let's try an example. A 15-kilogram package is being pulled across the floor by a tight rope with an applied force of 50 newtons. Calculate the acceleration of the package if 10 newtons of frictional force acts upon it. So using the formula F net equals ma, we plug in the elements. So T minus frictional force equals ma. Plug in the numbers. 50 minus 10 equals 15a. Solve it and you get a equals 2.6 meters per second squared. After 2 comes 3, so Newton's third law says forces always exist in pairs. For every action, there is an equal and opposite reaction. For example, a book sits on the table. The table pushes the book, and the earth pulls on the book. Forces of friction oppose the applied force. It only depends on the material sliding against it, and there are two types. Static friction is that friction that keeps an object at rest and prevents it from moving. Kinetic friction acts during motion. The coefficient of friction is mu. It only acts between the object and surface. Let's find it. A 50 Newton force applied horizontally is required to push a 10 kilogram cat at a constant velocity across the floor. What is the coefficient of friction between the cat and floor? So to start off, we always draw our free body diagram and then the two equations, x and y. Let's start with y. F net of y equals ma. The acceleration is constant, so it's 0, which cancels out ma. Then we plug in the elements, which is n minus mg, so n equals mg. Now we move over to the y side, the x side. F net of x equals ma, but it's constant, so it equals 0. Then the applied force minus the frictional force equals 0. Well, frictional force equals mu of n, and n equals mg. So we get Fa minus mu mg equals 0. Fa equals mu mg, so mu equals Fa divided by mg. Plug in the numbers. 50 divided by 10 times 10 equals 0.5. 0.5 is our coefficient of frictional force between the cat and the floor. Moving on to tangential and centripetal acceleration. Objects in circular motion always have a tangential speed. It is not the same for any 2 points in the circle. The tangential acceleration equals radius times angular acceleration. Centripetal acceleration is center-seeking. It is velocity squared divided by the radius. And lastly, gravitational force exists between two masses. The object will always attract from each other. It's proportional to distance between the two masses. The equation is the gravity times mass 1 times mass 2 divided by radius squared. We would use it to find gravitational attraction between objects apart from each other. And now for physics in the news. A new baseball pitch baffles physics because R.A. Dickey's pitches so unreal. Instead of curving the ball or throwing it as hard as he can, he pushes the ball so it floats in a straight line right to the plate. He does this in 55 to 80 miles per hour. The ball barely spins at all. His speed is lower than others, but the direction and angles are more precise. Those studying physics are trying to see how this is happening. He has won multiple awards for this pitch.